Hello, I'm Max Wessels. I'm going to give you a short demonstration on the project I've been working on this theme. We were asked to make a sensor system that could automatically analyze the soil, and this is what I've come up with. Basically it uses strips which change on different concentrations of nitrates, phosphorus and pH in the soil, especially in the groundwater, and they're basically like pH paper. They change color according to the concentrations. So what I've made is a LabVIEW VI that will automatically read the strips and give the concentrations. But like I said, the strips do need water, so therefore I also integrated a water sensor, which you can see here, and the whole program won't execute unless there's water present. So I'm gonna now give the demonstration. So my program is already running, and what should happen is that the LED, which indicates if there's sufficient water, should turn on when I would add water. So I'll add water now. First I have to open the bottle. So that should be sufficient. So now the LED is on and the camera is also taking pictures now. The camera is located in this black box. And basically what's in there is a camera and a light source to make sure that there's a nice light source which is constant, and it basically looks like this. So on the one side you have the light source, on the other side you have the camera, and in between there's a cardboard wall with a hole in it where the strip goes in. The strip will be put in at the arrow at the top, which is basically where the light is coming from in the picture. So here I have the different strips with the different concentrations. I will start with the strip for 0 ppm. These are the ones for nitrogen. So I'll insert it into the box, and then bingo, I've got the concentration of 0 ppm. It's a message that will pop up. So my camera can fixate on it. Yeah, you can see it, but it's not too clear. Well, it says 0 ppm, 0 parts per million. And I'll press OK, and then it will start running again. So then I will take this strip out. Take the 10 ppm. I'll just put that into the box. And there's still enough water, so then it will still keep running and running. Later on I will explain how I want to automate the whole process with this, using this. But for now I'll just demonstrate how it's working. So now I've put the strip in, and now it gives a message for 10 parts per million. Excuse me for the bad quality, but you can maybe see that there's a 1 in front of it now. Okay, so I'll take this one out, and I'll take the, well, there's also one for 250. I'll just take the one for 500 now. Otherwise it might get boring for you guys. So I'll put in that strip. I'll press OK because I didn't. You have to press OK, then it will start running again. Here, and now it gives a concentration of 500 parts per million. So basically what I've developed is a system which checks if there's enough water, and if there's enough water then it will automatically read out a strip or a color code from the strip, and will display the message, a message to the user with the concentrations that are that those colors indicate. So what I've come up with is this VI, and basically what it does, here you have the water sensor part. If there's enough water, then it will execute the whole program, which is in a case structure. Then the vision acquisition will take a picture, and then it will send it to all the 4 different areas, which are for the 4 different strips. Of course you can make more of those if you would have more time to develop it, but I just chose 4 random concentrations. So what it does here, the image goes through to, for instance, 0 to 500, concentration of 0 parts per million. It will start at the pixels 380, 1380 and 1315. It will then check if it's within range of the RGB code of 200, and 169, and if it's within that, then it will send a true to this AND function, and the AND function, if they're all true for the 0 to 25 part of the strip and the 0 to 500 part of the strip, if they're both true for all the RGB codes, then it will display the message with the concentration. So that's basically how the program works, and how we've thought up to automate this whole process I will explain now. What you can see here is the picture of a rough sketch I've made on what I think could possibly be my system integrated into a fully automated soil analyzer. So at number 2 you will have the strips, which indicate different concentration. At number 1 there will be 2 light electromotors, which will power the transportation of the strips. First this one will go on, then the strip will go up, then the clamp, which is indicated by number 6, will grab the strip, then it will move from here into the soil here. In the soil we have dug up a part, and there we have put a porous rust-free steel tube, so that the soil can't go through, but the groundwater can. So there will hopefully be enough groundwater at all times, and if there's not, then the water sensor will detect it. It will also send a message to the farmer, and then he can irrigate the land, so there will be enough water. So the strip will get picked up, will get transported into the groundwater, then it will stop in the position it is located now, and then number 4, which is the camera, will take a picture of it, and there will be a stable light source, which is number 5. Then it will send the data to the farmer, and then the strip will stop right here. It will drop the strip into the strip container, which is number 3, and then the whole process can start over again. So this is basically the whole process which we've come up with so far in this theme on how to automate soil analysis. Thank you for your attention. Goodbye.